Well, thank you, everyone. As you'll recall from my talk yesterday when I was doing the background, supply chain and how it fits into our overall cybersecurity automation has been a topic of many of these villages since not the first one. I think it was the third, fourth, and fifth one had major focuses on supply chain. This one, obviously, we had a much larger focus on the Volt Typhoon, but I still did want to cover a little bit of supply chain and sort of the next three talks. My talk's sort of a broad brush. John's talk will go into a little bit more detail on something that one particular company is doing. And they'll finish up with a keynote from Alan Freeman from CISA on work going on in this area. Probably should have done them in the inverse order, but some of it's just how we worked out the schedule. It's interesting. I was looking for something to put on the something to do with supply chain to put on my title slide. So I Googled it, and all the images I could find on supply chain, none of them had software in it. Okay, so I just found that interesting. So I used one of them anyway to point out that the supply chain crowd has all these different things they look at. Yeah, and they don't happen to mention software. And as we learned from earlier talks today, particularly from Neil's, mentioning that, yeah, but everything's based on software. We really should do that. So before we start, I did want to point out, remember that you will learn more about software supply chain if you actually play the game. Again, we still have real live money to hand out as part of not too far from now if you want to play. And we have well, I'll cover it a little bit in the talk, but a very nice book on software supply chain. And this is an autographed copy for anybody who happens to win the game. But start out, I did some informal polling yesterday. Raise your hand if you think you have SBOMs for any of the software involved anywhere in your company. Not everything has an SBOM, at least something has an SBOM. All right, so fair number of hands and a fair number of not hands. So that's useful too. But I did want to call out, and some of the people who were here yesterday who aren't here today, I again hit up with this question. And for the most part, the answer was yes. I don't know, Patrick, we don't happen to have SBOMs for this pile yet, though, do we?
We will. You and I will make that happen this
afternoon.
Get there.
We'll get there, but we don't always drink our own champagne as much as we should in general.
It's on the roadmap.
Yeah. So I did sort of want to point that out. But let's get into the actual supply chain use cases. And again, a lot of this will be review if you've been to previous villages. But again, as Neil mentioned, this is something out of an executive order from the last administration. That's a sentence written by a friend of Alan's and I's that sort of percolated up and made it into quote what the president said, that I thought would just be worthwhile repeating. Because again, it's not that we need everything to be at the same level of security that we need the nuclear weapons to be at, but we need it to be at the right level of security. And I think the Senate says it very well. And I think it's something that we actually don't do very well. And that's why we need to get better at the supply chain stuff. So we mentioned this term before, software bill of materials. It's basically what is the software, not just what's the first level of software, but what's the second level and what, all the way down the tree. This is from work that went on a number of years ago at NTIA when Alan was at NTIA. And he moved over to CISA because of that executive order that we just mentioned, sort of moved a lot of the work over into, it makes sense, the cybersecurity agency of the government. So they got a new logo when they did that. Did you bring stickers? I did. All right, so we have more stickers. And don't forget, we get some village stickers hanging around too. People need to pick them up too. So what is an SBOM? It's just like the ingredients. We use the analogy. It is just an analogy. All analogies are wrong, but some are useful. This is a useful analogy of it's similar to having the ingredients list for food. It's a little bit different because there's usually layer upon layer upon layer. It's usually different because actually most people don't actually know what's in their software. That's sort of the root of the issue. I mentioned this book. It's by a friend of ours, CASP. Like I said, I'll be giving out one of them to the winner of the game. But even if you don't win it, I do recommend you get it and read it. It's very useful reference material. So I'm not going to attempt to cover everything that's in there, but I will touch on some of it. And notice it does have software, firmware, and hardware. I'm sort of focusing on the software. You would not believe the amount of arguments we have on whether firmware is software or whether firmware is hardware. But since many of you are involved in standards, you probably would believe the arguments that we have on it. But one of the things that came out of these groups is sort of classifying, simplifying, makes it easier to think of, you fall into one of three categories. Again, most people will fall in all of them, but from a role viewpoint, you look at people producing the software, the people who are deciding what software to use. And I always like to point out, this is two different categories of people. One is the people who are the actual software developers who are deciding to use all those things that you're dependent on. Most software is 90% other people's software. So the people who make that decision that I'm going to use Duncan's untrusted GitHub repository, do that, you're pretty foolish. But again, you're making that choice. That's you're the one choosing that software. And then the other is I'll call it the acquisition people, the people who are actually the purchasing organization of your company, because they're deciding to use, Microsoft Office versus, I don't know, whatever the other choices are. And then there's the people who use the software. I do not know of anybody who does not fall in this category. If you're employed by some company, your company has some software in it it's using for something. Even if you're a taxi driver, even if you're a hairdresser, there are still software systems that support those businesses. You're at this conference, you're probably neither of those. You're probably much more of a tech-oriented person, and you're probably using a whole lot more software. So again, just produce, choose, or operate tend to be buzzwords we'll use in our use cases. Why are we doing it? Sure, you've all seen this XKCD cartoon before, but just use the example of, Log4Shell is one example, SolarWinds is another example, and XZ is yet another example. And those three are sort of three I would consider escalating sophistications in attack. One made use of an existing vulnerability. One should have backed up and said it at this point. So this sort of, hey, there was a bug there. It was actually in there for a long time. Somebody figured out how to exploit it. Whoop. This one was, hey, if I can get into your build chain, I can throw some extra stuff in. So similar to the example that I used in one of the talks earlier today of the sort of malicious data going in as part of the model of the malicious code going in as part of the model of the AI. SolarWinds was an equivalent case. You sort of got into the building of the thing. And then I think this is even more sophisticated, open source project used by many, someone over many years built up a trusted relation with the open source community. So on a given day, they could stick their bad stuff in. And I'll say that one got caught by pure luck. That one wasn't a bigger deal because it got caught fairly quickly because that particular open source somebody happened to look at. They say open source is a much higher security because many eyes make it more likely to catch it, but you actually have to have the eyes looking at it. In this particular case they did, which was good. So why does all this matter? I include this slide. This is from Jerry Maguire if you haven't seen the movie. But I use the slide in all my talks because the reality is that's what drives decision making. So it's really all said and done a risk, probability of risk, probability of making or losing money associated with it. And so we need some of that. So I'm going to very briefly go through a bunch of real life data, mainly just so the slides are in there so people can use them of various cases that have actual real world data. The previous talk used a real world IBM case of, hey, they may have found this kind of efficiency. So why is there some savings in having a more transparent software? Transparency before we get into the actual use cases. Why should anyone care? What we call the value proposition. It's because it's going to either save you money or make you money, depending sort of on how you look at it. So one of the work streams that Alan prompted as part of the work in CISA getting industry together was sort of why boards should care. This is from another talk I gave somewhere else. It's a whole talk, so I'm going to use one slide from it, be really quick on it. But it's also not why should boards care. It's why for basically everybody in a corporation should always care about what boards care about. So sort of looking at it from both sides. But I'm sort of just really focus on really throwing this up there so that it's again in the slide deck, not totally covered. This is sort of our one slide version of if you are having to brief your board on why you should care on software supply chain. This is sort of what you'd use, what you'd customize for your own particular case to make the argument. And I would argue everybody in any corporation anywhere should be looking at it from well, if the board cares, care about the mission of my company, I should care about the mission of my company, so therefore I should care. And again, tailor it to your particular role in your particular company. Again, there for reference. We actually were talking a little bit earlier, John and I, we mentioned this is from the NTI work from quite a long time ago, when we sort of started out with, hey, what's the scope of software transparency? And then the reality is we spent all our time in the darker green box for most of the effort. And I'll even say still most of the effort. We started getting into APIs and things like that. But this is from years ago, as you really have to care about all this stuff. We're beginning to cover more. So I always like this diagram as sort of a reference to everybody to have a copy of, particularly when talking use cases. And then, all right, so why should you care? Well, you care, hey, security advisories are going to come out. When they come out, they're going to tell us about the patch. Hey, we put the patch in. Oh, by the way, tend to come out after a really long time. The hackers don't wait then. The hackers don't wait for the advisory to come out and you to put the patch in. They're usually in there before advisory came out, or even the patch comes out. Again, case study by MedCrip, real numbers, real savings, a pretty big number. And it's not, it's not on the Fortune 100 list type company either. They're not that big a company, and they saved a really lot of money. Army, one other reason, if you're a government contractor, hey, you might care because they're going to basically make it part of their procurement specs. Friend of mine, Dimitri Raven from Cybeats, I think it's going to be in John's talk later. Also, there's this whole concept of shift left. You want to do things earlier in the development cycle. Knowing what your software is very important to that. But it's also important to shift right in that it might be, hey, your software is already out in the field. Everything's all there. And then we discover there's a vulnerability because you're using some dependency that didn't have a vulnerability when you used it, but it has it now. Okay. So it's not just a shift right, it's also a shift left. You actually have to make it part of your operations as well. Some data from Cybeats on some improvements they saw on particular projects. Some from SUSE. Again, these are, to be honest, Cybeats, SUSE, John, when he talks, these are vendors who basically help you with this problem. So obviously they're going to be the ones that, find the things that look best from their viewpoint. But the reality is their customers really are saving money. And if you read this book by Cassie is not a vendor in this space. She uses the vendors in this space, and she's got great, in fact, I got one of hers coming up too. So it isn't just the vendors saying it, but vendors are a good source of data for this kind of stuff when you need your justification for doing it. This was from a person who, I can't say what company they worked at, but wanted to use the example of when Log4j came out, how bad it was, and how basically the org that was prepared in this way, it was a piece of cake and not that, it was a hassle, but it wasn't that big a deal. The org that wasn't prepared, it was a real big hassle. Similar, some work from Bruce, one of our friends of ours at Oracle, has had some data out there on it. Again, including this so everyone's got it available. Cassie, the author of the book, Snyder Electric, again, they did the business case on doing all this on basically saving money. It's basically they need less people to deal with this stuff when you do it right in the first place. One company that was attributable and actually published a public paper on this was a Southern company, a huge electric company. Did a study on a very small, just a particular substation. The substation had 38 devices from 17 vendors, and it took 2 years for them to actually get it all straightened out. Okay, and that's not a good thing from looking at, am I still going to have electrons tomorrow coming out of my blood if something bad were to come about. So let me now jump to, again, those of you who've been at previous ones of these, this is not like Olympic Destroyer or Volt Typhoon where we're using real data. This is a made up use case. I tend to be more from the, because of my experience, we talked about sticks a little bit earlier today. We talked about sticks a lot yesterday. Neil mentioned sticks earlier today. From my 5 years of trying to get sticks adopted in an international standards body, it is adopted as an OASIS standard. It's not adopted. In fact, hopefully it'll be adopted. We mentioned Mike Rosa going over to Geneva next week. It's a small chance it'll get adopted next week. We've been trying for a long time to get sticks adopted as a worldwide standard because particularly a lot of the developing countries can't actually use it unless it's a ITU or ISO standard. And for some reason, the Russians and the Iranians don't want us sharing threat information. That's been really good keeping us from getting it through. But anyway, because of that, one of the tricks the Russians in particular used to to keep us from getting STIX adopted is in the appendix, we had some real life examples of how STIX was useful. Happened to be Russian attacks. Russia wasn't really keen on having their attacks built into international standards. And once they got pissed at us, it's been an uphill battle ever since. So I tend to use non-attributable made up examples in my use cases. But anyway, this particular one is a hypothetical 6-day event that I'll go through real quick. Again, slides are in there for people to look at. The link is in there for people to go read. We've covered this in 3 previous villages, so we're not, having our pies pull our S-bombs from the other ones and do the actual stages of this like we did. Actually, the last one, we did some of that. And hopefully at the next one, once we get Patrick's stuff all up and working, we'll do it at the next one. This one, I'm just going to cover it verbally. Starts out with Murphy's Law Firm. Okay. We named Murphy's Law. They get hit with a very bad attack at the absolutely worst time. But because they implement this alphabet soup that we've been talking about, they recover really quickly and everything happens really nice. And we actually go through all the details of how you use STIX, how you use Cacao, how you use OpenC2, et cetera. And this is sort of what we call the something value. I don't know. This is sort of the value proposition. This is the value proposition use case that hopefully people who aren't as techy as all of us could read and say, oh, this is funny. Oh, but I see how it's actually useful to do. And then what we call the practitioner use cases are the actual, no, here's the actual Cacao playbook that does this. Here's the decision tree, you do it. Here's the OpenC2 commands you get. Here's the SBOM that had it. Here's the CVEs.
This meeting.
Thank you, Patrick.
I agree.
So that's the 0-day attack. Day 2 is, hey, we still haven't patched it. We still haven't figured out, but another company gets attacked and it's On Deck Holdings. You can sort of play on words of it's on the second day. But they, again, nothing bad happens because they're a member of an ISAC. The Murphy's Law Firm was a member of an ISAC. It shared the information via STIX. They had the information. They knew how to deal with it. They knew how Murphy's Law handled it. So they knew how to deal with it. We were talking yesterday about the playbooks and the sharing of playbooks. All that magically occurs in this particular use case. And again, they come out feeling good. Triumphant Cleanup Company. Triumphant because it's the 3rd day cleanup. Because, hey, in this particular use case, it's no longer a 0-day. We've had time to figure out the particular CVE that was exploited. We can sort of break their attack chain at a particular point if we do our patching right. So they've went out and gotten the information, decided what to do about it. They have 70 devices with the components, but they have VEXs for 35 of them that say, hey, it's not really affected. So I think it's 35, whatever the right number is, 30. 30 of them actually do need patching. They go and put the patches in. So they don't patch what they don't have to. They do patch what they do need to. And again, they don't get attacked in the first place because they don't actually have the thing the attacker needs. Day 4, again, hypothetical use case, so we don't use real names, but there's this thing called the Never Say Anything and No Such Agency. It's a part of the U.S. Department of Useless Factoids. So you might guess where that might come from. Fortunately, Neil's already left. And they're a government agency that's responsible for protecting parts of the rest of the government agency. And they have this comply to connect use case. If you recall from my talk yesterday, comply to connect was the use case that's sort of, hey, I don't hook stuff in unless I know what's in it. Well, hey, knowing the software of what's in it, do I have the SBOM for this device is part of the use. That's where that fits into this particular use case. And then, because we want to involve other parts of, we heard the talk yesterday on NEEM Open, we want to get law enforcement and the courts involved in the use case. We actually, hey, law enforcement goes out and goes against it, goes arrests a bunch of the attackers or whatever. That happens here. It's a criminal takedown across 6 countries. They use that NEEM Open standard we talked about yesterday to share the information across that. And then day 6 is they discover that, hey, maybe that criminal gang had some help from a foreign nation state, and we can't talk about how the NEEM Open classified stuff gets involved, but magically, us and some NATO allies go and involve some server farms in other countries or whatever. So again, that's sort of the big picture use cases that we're using associated with software transparency. We have demos that do all this stuff, but that was at previous ones. We're not spending it, we only have so much time in the 2 days. So this is sort of about how much we'll cover it, but John will give some examples later. And Alan will talk about some stuff we're doing. With that, Oh, I should have mentioned this. So this is across, again, this is actually our slide from last, maybe from 2 ago, of our villages, of the different, both piece parts and organizations that were involved in actually showing real stuff, talking to real stuff using these examples. And again, we didn't do the law enforcement or MilOps ones in real life, but we did do the 1, 2, 3, 4s in real life. And that's it for me. I have 4 minutes for questions. I think I have 4 minutes. Any questions? Anybody awake? Alan?
Go ahead. I can talk to Duncan all the time about SBOM.
What's your assessment, looking a year back? You know, what progress have we made, and where should we focus next year so that we're in a different place than we are now?
Well, one progress we have is, I don't know if you recall, but I asked that same SBOM question last year, and I don't think any hands went up. So other than mine, because I should have pointed out the game you're all playing, if you look across the top, there is a link you can click on. It goes the same thing with .wellknown/SBOM, then it gives a list of the SBOMs for that release, which if you look closely, that release was only made Monday night. So because kind of started on, well, the prep started on Tuesday. So it might even been from, I take it back, it's from Tuesday night, this conference started on Wednesday. But again, so I should raise my hand there too. So first of all, it's getting wider adoption. We're still, like to say, the future is here, or the future is here. It's just not evenly distributed. So the distribution is increasing a little bit. I think the need increase a little. I think we need to really get into using I think it's the day 3 use case. We really need to get into the, hey, not only when I get to that decision tree that says, hey, is this CVE affected? And Duncan's blinky box that I showed the other day that's pretending to have the vulnerability and the lights change when it gets patched. We need it to be not just Duncan's box that does that. We need it to be a wider number. You know, does OpenVAS have an SBOM, and does OpenVAS have the ability to, you know, take an OpenC2 command to put the new version in, etc. We've written some code. AT&T actually, AT&T, Patrick, AT&T actually contributed some code to OpenC2 back 5, 6, 7 years ago. By the Mike Snare wrote on basically, hey, we have OpenC2 commands, but none of the cloud providers actually accept them. So we actually wrote API code that accepted the OpenC2 command and turned it into the, like, hey, I want to instantiate a GCP machine or whatever. And he did that. We need to probably do more.
Yeah, I tried to get him back in.
Well, and I've written some code to do it too, but I need to get back to it. Alan, you were next.
So if we're in a world where we're going to be depending on voluntary collective action to make collective progress for a short time.
Sort of how this group works.
Exactly. What are some of the things that you think will have the greatest impact, you know, from collaboration? Community can come together and say, we're going to work on X without the ability to force anyone to adopt what comes out of that. What would be the most useful?
So
Asking for a friend.
I used a slide yesterday that I didn't have in this particular deck because it was the automation slide as opposed to the SBOM slide. But similarly, I had a slide on automation on how much the John Hopkins study that showed on how much money it saved. These ones were on how much money they saved. I think the problem with groups like this is it's exactly what you just said. It's basically, we're all here as volunteers. Some are totally volunteers. I'm not being paid here to be here at all. Some are, you know, Patrick convinced AT&T he could use a little bit of his time in this particular case, also travel. A lot of people that are on virtual or because they couldn't even get convinced to do travel, but they at least could be allowed to use the time. But all said and done, I don't know of anybody that this is their actual job. So we're sort of all here as volunteers. The value of it, though, is that those monies being shown, the money you've shown by automation, the work we do today will generate those kind of money savings, I'll say 3 to 5 years from now. I'd like it to be 1 year from now, but things never happen as fast as I would like. It just takes a while for the future to get wider distribution. But I think my biggest value would be is because we did that, what we talk about as the cyber rich, security poor. I don't remember the exact phrase Josh used.
Target rich.
Target rich, cyber poor groups. I think it came up in one of the talks yesterday about the utilities. Most utilities in the US are lucky to have an IT person. They don't have a security person. Water systems are even worse in that area. So there's an awful lot of the critical infrastructure of the US that's unprotected. And there's an awful lot of just the plain old rest of the US. Doesn't have to be critical infrastructure. It's just, you know, the building down the street that we're going to for coffee or whatever, that isn't protected. I think standards, particularly the interoperability and the standards and the sharing the information, are actually the greatest benefit for those that don't even know they're getting the benefit from it. They pick it up because we increase the quality of everything and we make it more accessible to them. I don't know if Kyle's here today or if he's only on. Oh, Kyle's back in the corner. So Kyle's business model is to sort of go after that, the smaller people who can't afford to do much of this. So it's sort of like the virtual CISO model, sort of the virtual SBOM support to the virtual CISO model. By our doing our work, we allow that kind of stuff. We allow the stuff going on in us undisruptible 27 happen. So I think, and I got to shut up. So I think the greatest long-term value will actually be in that area. But I think the shorter term will be in the just the adoption and the standards that we're using today that were developed in the past are showing the value today. So it's fortunately it's a future thing, but it's not that far in the future.
Hey Duncan, just a quick follow on. Are there any
Really quick, because I'm
are there any efforts underway like with DFARS that force the DIB industry? Are there any efforts to make this part of contract, government contracts,
you should.
which would drive, I think?
I'll answer that so Alan doesn't have to. So they've been going much slower than anticipated. But that executive order that I showed a piece of before actually gave instructions on that should occur. It's actually been in, first of all, you mentioned both FARs and DFARS. So it's not yet in the FARs. It's actually been in the DFARS for a while. It's an optional line in the DFARS. They helped me to it back in 2004. Okay, it's actually been in the DFARS. That's how I got involved in this field, was because on an AT&T contract for a very big, first of all, on a classified contract, that wasn't so bad. But then on a very big open project, they said, hey, you got to do configuration management on everything, including the software versions of $100 million government network. It was a royal pain in the butt that I fought tooth and nail, and I've been the biggest advocate of this stuff ever since.
And that would drive like open, if we want to use open source and so now all of those things now have to get subsumed into that for us to be able to make money.
Cyber Resilience Act is probably the biggest piece of regulation that's happening now. That's in Europe. That will say every software product that's not covered by other regulation includes an SBOM requirement. And then we're starting to see some stuff from individual agencies. The Army has a memo that says all the software be Army licensed.
Yeah, I threw the Army one up there.